Today, we're going to add mixed numbers using standard algorithms and properties of operation. So, let's just dive right in. I'm going to look at numbers 3, 6, and 7 to start. Number 3, 1 and 7/8 plus 1 and 2/8. Step 1, add the whole number. 1 plus 1 is? Yeah, it's 2. 7/8 plus 2/8 equals how much? You're right, 9/8. Very good. I can't leave it this way because 9/8, the 9 is too big. It's too great. My number has to be 8 or less. So what I'm going to do, I'm going to show you 2 ways how to do this. So you have options on how to best help you. The first way, we're going to decompose 9/8 into a whole and a piece left over. The second way, we're going to do subtracting from the fraction to give to the whole. So to decompose 9/8, I have 2 plus, how do I say a whole using eighths? Yeah, it's 8/8. 8/8 plus 1/8 because 8 plus 1 is 9. So 2 plus a whole gives me how much? 2 plus a whole gives me, yeah, it's 3. And then I have 1/8 left over, so 3 and 1/8. Now, I'm going to bring my thinking for the other way over here. 2 and 9/8. Again, I'm going to take away a whole because I have enough to. But what I take away, I have to give over to the whole number. I took a whole out, so I have to give a whole to the other whole. 1 plus 2 is? Yeah, it's 3. 9 minus 8 is 1, and the denominator never changes. 3 and 1/8. Let's look. Let's look at number 6. 6 and 5/12 plus 4 and 11/12. Step 1. Right. Add the whole number. 6 plus 4 equals, you're so smart, it's 10. I know my denominator never changes. 5 plus 11 is how many? 5 plus 11 . You're right. It's 16. 16/12. Now, do I have to change that fraction or can I leave it? You're right. I have to change it. 16 is too great to be on top of 12. So, again, we're going to do both ways. We're going to decompose it, and then we're going to do Miss Stephanie's way of just subtracting out the whole. So, we're going to decompose it up top. 10 plus, I know I have a whole, so I'm going to say 12/12. From 12 to 16 is how far? How many more from 12 is 16? How far do I have to go to get from 12 to 16? Yeah, it's 4. It's 4. So, following my thinking arrows, 10 plus 12 twelfths is the same as saying 10 plus another whole. That gives me 11 plus 4 twelfths, 11 and 4 twelfths. Or you can do it Miss Stephanie's way. Say 10 and 16 twelfths. 16 minus 12, 10 plus 1 because I'm giving away a whole, and it's catching the whole, is 11 and 4 twelfths. Now, let's look at number 7. 2 and 1/3 plus 2 and 1/3. Step 1, add the whole, right? Yeah. What's 2 plus 2? You're right, it's 4. 1/3 plus 1/3. You're right, it's 2/3. Now, here's my question. Can I leave it or do I change it? You're right. Leave it. It's fine the way it is. Let's look at number 12. Actually, we're going to change that. Let's look at number 9. And then we're going to look at number 17. So I'm just circling my thinking ones. Number 9. It's going to walk us through. It says add the fractions, add the whole numbers, write as a mixed number. We can do that. So step 1, it says to add the fractions first. We can do that. 3/6 plus 4/6 is how many? You're right. 7/6. Good job. 1 plus 2? Way to go. It's 3. Can I leave it this way? No, I have to change it. Do I have enough to take one whole out of my numerator? Yeah, I do. So I'm going to say minus 6, and then where I'm taking away a whole, I have to add a whole. 1 plus 3 is 4. Good job. I know my denominator is 6 because that never changes. What is 7 take away 6? Way to go, smart humans. It's 1. So 1 and 3/6 plus 2 and 4/6 equals 4 and 1/6. Now, let's look at 17. 5 plus 3 and 1/8. This one's tricky. Step 1, add your whole numbers, right? What's 5 plus 3? You're right, it's 8. Do I have any fractions to add in over here? Nope, so I can just say 1/8. And I'm going to leave it that way because there's nothing left to add. There's nothing left to change. So 5 plus 3 and 1/8 equals 8 and 1/8. I hope this has helped, and I'll see you again really soon.